Okay, hello and welcome to day 5 of Advent of Code. We currently have 8 stars here. We managed to solve both puzzles every day. Yesterday took me a little longer than the other puzzles. The difficulty is definitely starting to ramp up, but it's all doable. It is all doable. Now, we've got a little bit more of a picture here as we're going through the days, and I'm starting to think that this might be like an island, and these like tildes, these squiggles here, these might be the sea, maybe, around some kind of little island here. I have no idea. Anyway, let's not speculate. Let's jump right into this and get started on day 5's challenge. So let's have a look. Binary boarding. You board your plane only to discover a new problem. Oh yeah, if you've not been following along for the other days, this whole problem situation is based around us going on holiday. So you board your plane only to discover a new problem. You dropped your boarding pass. You aren't sure which seat is yours, and all of the flight attendants are busy with the flood of people that suddenly made it through passport control. That's what we did yesterday. We finagled with the passport checking. You write a quick program to use your phone's camera to scan all of the nearby boarding passes, which is our puzzle input. That was good of us. Perhaps you can find your seat through process of elimination. Okay, cool. Instead of zones or groups, this airline uses binary space partitioning to seat people. Obviously, all the good airlines use binary space partitioning to seat their people. A seat might be specified like FBF, BB, RLR, where F means front, B means back, L means left, and R means right. The first 7 characters will either be F or B. These specify exactly one of the 128 rows on the plane, numbered 0 to 127. Each letter tells you which half of a region the given seat is in. Start with the whole list of rows. The first letter indicates whether the seat is in the front, 0 through 63, or the back, 64 through 127. Okay, so this is a binary search. Cool. We just got to implement a binary search, I think, maybe. Maybe it's a bit more complicated. The next letter indicates which half of that region the seat is in, and so on until you're left with exactly one row. For example, consider just the first 7 characters of FB, FBB, FFRLR. Start by considering the whole range, rows 0 through 127. F means take the lower half, keeping rows 0 to 63. B means take the upper half, so the upper half of 0 to 63 would be 32 to 63. F means take the lower half, so we keep rows 32 to 47. B means take the upper half, so we take rows 40 to 47. B means keep rows 44 to 47. F means keep 44 to 45. And the final F keeps the lower of the two, row 44. So F, B, F, B, B, F, F. That gives us row 44 out of a possible 128 rows. Then the last 3 characters, so we've got RLR, will be either L or R. These specify exactly one of the 8 columns of seats on the plane, numbered 0 through 7. The same process as above proceeds again, this time with only 3 steps. L means to keep the lower half, while R means to keep the upper half. Okay, fantastic. So for example, just consider the last 3 characters, so RLR here. We have the whole range, 0 to 7, that's our row. There's 8 rows in this, 8 seats in this row, okay, and there's 128 rows on the plane. So R means take the upper half, so we keep the 4 seats 4 to 7. L means take the lower half, so we keep seats 4 to 5, and R means we keep the bigger of the 2, the upper of the 2, so we take seat 5. So this instruction here reveals that it is the seat at row 44 and column 5. Every seat also has a unique seat ID. Multiply the row by 8, then add the column. In this example, the seat has ID 44 times 8, add 5, because it was in row 44. We multiply that by 8, and then we add what seat we were in, which was 5, and we get 357. Here are some other boarding passes. So we've got some test data here. So this will give us row 70, column 7, seat ID 567. This will give us that. This will give us that. As a sanity check, look through your list of boarding passes. What is the highest seat ID on a boarding pass? Okay, there's a bit going on here. I don't think it's not really as complicated as I thought it would be. So He says now, let's have a look at our puzzle input. Yep, great, there is. Oh, he thinks it's in Welsh. That's amazing. He's trying to. Do you... Oh, look, there's no vowels here. It must be in Welsh. No Google Translate. No, it's in English. We'll leave it in English. But thank you anyway. So we'll take all of these boarding passes and we'll put them into our code. So Control A to select all, Control C to copy, and let's jump into REPL.it where we'll be writing our code. So I'm going to just jump into my 2020 folder here, and I'm going to add in my files for day 5. So I would like day5.py, and I would also like my day5 data.txt. Lovely. And we're just going to paste that data into here. 798 boarding passes. What a lot to look for. Can you imagine doing this manually? Like before computers existed? This would be ridiculous. Right, day 4, let's just copy this and pop it into day 5. We're going to change this to day 5, lovely stuff. And we're going to update our REPL.it file right now so that we are running day 5, not day 4. Lovely. So when we press the run button, we want it to use Python 3 as the language, and we want it to run this file inside the folder 2020. We want it to run day5.py. Fantastic. So let's grab in our test data, just like we've done every other day. So we've got some boarding passes here, and we know what they should be equal to. So let's grab these. Actually, let's grab these. And I'm just going to pop them into here. And we're going to say test data as always, and we're going to store them in a list as always. It's starting to kind of get a little bit of a system here. So what I'm going to do is I'm going to store the values of what the test data should be just below it. So our test data is going to come in as strings like this. And so I'm going to take this one and pop it here. And I'm going to take this one and I'm going to pop it here. Oh, didn't want to do that. Let's do Shift 2, not Control 2. Paste that there. Okay, lovely. So we've got our list of test data, and down here we have got what we should be expecting from each element in that test data. Okay, so we should be getting row 70, column 7, CID 567. Okay, so what we are essentially doing is a binary search here. And so we have our seats, and they are in rows of 8. So we want to, what do we want to do? We want a kind of position, I guess. So what we want to do is we want to say, let's define a function called search. And what we're going to do is we are going to take in that string. So what is this? The boarding pass. Is that a boarding pass? Is that what they're called? Here are some other boarding passes. Yeah, okay, fantastic. So we've got a boarding pass, and we're going to go through each letter in our boarding pass. So for, let's say, instruction in boarding pass, and what this loop is going to say is when we pass in a boarding pass, which is going to be one of these strings here, we're going to look at each letter in that string. So starting at here, so B, and then we'll look at F, and then we'll look at F, then we'll look at F, and so on and so forth. So for each instruction, what do we want to do? Well, we want to have a upper and lower bound, I guess, don't we? Let's say upper bound. Actually, we probably want to say, let's call it a position. And that's going to be an empty array. So let's call this row position. And we're going to start, it's not going to be an empty array, we're going to start at 0 to 127. Okay, so that's up here in the thing here, it says there are 128 rows on the plane numbered 0 to 127. So what we are going to start with are rows for the minimum of 0 all the way up to 127. So we're going to model that here using this array. And we're also going to have our seat position. Do we want our seat position yet? Let's not get ahead of ourselves. Let's start with the row position. So for instruction in boarding pass, let's do if instruction is equal to a B or instruction is equal to an F, then we are going to do something. else, or elif, should we say, elif instruction is equal to, actually, do I want to do or? Maybe I want to do this and split them into their own elifs. So let's do elif instruction is equal to f, elif instruction is equal to right, and then we're going to say elif instruction I can't spell, instruction is equal to left. So instruction is back, front, right, or left. I think that's back and front, right? Backwards, forwards. So I did in the front or the back. Okay, and so the front will be 0 up to 63. So 127 over 2. Let's just open to Python 3. So 127 over 2. That's 63.5. So we're rounding down. So we are saying if it's in the back, we are rounding down. So we're going to go. Sorry, if it's in the front, we're rounding down. We're going 0 to 63. If it's the back, we're going 64 to 127. Okay, so we're going to say we're just going to work for the back first. We're going to say middle is equal, and what we want to do is we want to take this position here and we want to half it. So we're always going to do that. Actually, what we want to do is we want to say, because we could be in a position, let's do it on the second one. So we could be on 0 to 63, and then we could end up, where does it, let's change this to something a little bit more helpful, 32 to 63, okay? So if this is 32 and this is 63, then we don't just want to half this, because that's going to give us, what's it going to give us? 31. It's going to give us 31, and that's not going to be helpful. So what we want to do is we want to essentially get the row position at position 1, so this number here, and we want to take away row position at position 0, so this number here, and then we want to half it. So we're going to say row position 0, so we're going to do this number here, take this number here, and we are going to then divide it by 2. And we are going to want to take that, if it's the back, we're going to want to take that to the floor. So we are going to say, what we're going to say, we're going to say, can we say math.ceiling? Python floor. How do we floor something in Python? Floor? Math.floor. Import math.floor. Okay, great. So let's import math. And down here we can say if it's the back or front. I keep getting confused between the back and the front. It's not quite what I expect it to be. So if it's the front, we go 0 to 63. So we round down if it's the front, or we round up if it's the back. So in here, if it's the back, we're rounding up. So we're going to say middle is equal to middle math.floor, or floor of the middle. And in front, we're going to do exactly the same, but we're going to do math.ceiling. And what that's going to do is it's going to round it up rather than down, i.e. round the right way. Okay, to double check that, I really want to make sure F means take the lower half, 0 to 63. So we're rounding down. So we're flooring, F means take lower half. Okay, I'm just going to pop that in here. F takes lower half. And B takes upper half. Okay. What our new value here? So let's go over to the example. So we start with 0 through to 127. So let's put that back in. So 0 here and 127. then take the lower half, so we keep row 0 to 63. So with F, what we are doing is we are updating the second number to what we've just worked out, that middle value. So we're going to say row position at position 1 is now equal to middle. However, we're taking the top half, so down here we're taking the upper half. When we work out what the middle is, we're going to change the first value. So 0 becomes 32 here, 63 stays the same. So we're going to jump into here. Sorry, I'm going to put this at the start because I keep flipping through these really badly. Let's copy that and let's come down here and let's say row position 0 is equal to middle here. Okay, so if it's instruction is B, we're going to work out what the middle value is and we're going to update this because we are then going to say that's now 63. However, if we're taking if it's front half, if it's the lower half, then we're going to update row position 0 to the middle. So then this would become, I don't know, whatever it would be, 32. And so that would keep updating it until they are the same. And I'm assuming this will just work. These are all a set length. So there'll be a set amount. Yeah, that would be fine. Then we're just going to do the same for seat position as well. So our seat position. It's going too well. I'm really worried. Oh goodness. Okay, we're going to do the same kind of thing here. But I'm assuming right is going to take the upper half. Let's just check this. So let's come down to it. Right means take the upper half. Okay. So we want this. This takes the upper half. Did I copy this from this? Let's just copy this. Okay. All we're going to do is we're just going to update the variables. So we are going to say right takes the upper half here. I'm going to say our seat position. So let's take this and updating our seat position here. Minus seat position 0 over 2. Middle equals snap at floor. And I'm going to say seat position 1 is equal to middle. Okay, lovely. I'm going to take this. I'm going to pop it in here. Now, this code is quite repetitive and I can think more carefully about how I how I do this. But hopefully this kind of makes it a little clearer as to what's going on. Middle equals seat position. Yeah, so we find the middle. We're then going to ceiling the middle here. When we take the upper half. No, when we take the lower half. Doing it, yeah. Are we there? To the left, take the lower half, keeping columns 4 through to 5. 7, 4 through 7, so we get 3, 1.5. What? Oh, okay. We want to find the middle value. Right means take the other half, so we keep column 4 through to 7, because half of 7 is 3.5, and so we round that up, take the upper half, and we round it up. So right, we should be ceiling. Okay. And lower half, we should be flooring. If I mess this up up here then, takes the lower half, 127, 63. So we want to floor with F. Are we flooring with F? No. Okay, I've goofed up. Floor, and I want the ceiling here. Important that we round it correctly, otherwise it's not going to work. Our middle, we find our middle position, okay, and then we drop down. So in this example then, once we get to here, 4 through to 7, we then find our middle value. So we do 7 minus 4, which gets us 3. But that's not what we want to do, is it? That's not how we're calculating it. We want to do 7 minus 4, which is 3. And then we want to half 3, which is 1.5. We then want to round it up and take it away from 7. 4 through 7. I think I've goofed up on the maths here. Let's have a look. Let's see this. See if this is working. So at the end, let's just do a quick print of row position, and let's do print of seat position. And what I'm going to do is I'm just going to run this search function with one bit of data. So we're going to say search with test data position 0. Search test data. Let's see what we get. Nothing, because it doesn't like this. I've missed out a colon. Error. 0, 3, and 0, 1. So it's not doing what we want it to do. Okay, it's not being clever enough. So what am I doing? I want to take the middle value, and if we want to take the upper half. So if I'm doing 0 through to 127, I'm fine. In F, I'm just halving this number, and that's fine. Okay, so in F, halving this, I'm flooring it because it's 63.5, and I'm rounding it down, and that's fine. Now here, to find the middle value, I'm going to do 63 minus 32, but that's not going to get me the middle value, is it? I want to do 63 minus 32 over 2. What do I want to do? How am I going to find the midpoint? Yeah, so actually, when I take them away from each other in here, so for B, when I take them away from each other, I then divide it by 2, and then what I want to do is I want to say my middle equals math.ceiling middle add row position 0. B takes upper half. So B takes upper half, so we keep this at position 1 the same, but when we are taking the upper half, we are then doing this. Okay, so what I want to do actually is I want to change this row position 0 to equal middle. F takes the lower half, so I want to update this. So I think on that, minus 14 minus 11. Okay, something's not going quite right there, but I think we're getting there. So math.ceiling of middle add row position 0. So if our row position is at 0, we want to add 32 to it. Which is half of 63 pushed up. Okay. So actually what we want to do is we don't want to do this. We want to do row position. I've confused myself here. Oh God, it didn't take much, did it? Okay, B means take the upper half. I'm just going to copy this. I keep coming back to this page. Let's just copy this. Yeah. Oh, I said at the start that this was getting easy, and now that word has come to bite me. Okay. B means take the upper half, keeping row 32 to 63. F means take the lower half, keeping row 0 through to 63. So when we do F, we are wanting to half this number here. So our middle is equal to our row position at position 1 over 2. divided by 2. And then we're going to floor that, because it's going to go down 63 rather than up to 64. And our row position is going to equal the middle. Now, what happens when this is 32 and we want to take it downwards? If we half 63, what we're going to get is 32. But that's not what we want. We want the middle number between 32 and 63. So really what we want to do is write a function. This will make things much easier. F get middle. We're going to pass in num1 and we're going to pass in num2. We're going to pass in two numbers. Let's say we're going to pass in. I always feel so much more like I'm about to solve something if I write a new function. So I'm going to say big number and I'm going to say small number. And we are going to say, how do we find the middle of something? Well, we're going to do number minus the small number equal to big number minus the small number. We're then going to say that we want to half that difference and add it to the small number or the big number, it doesn't matter. So we're going to say middle is equal to the small number, add, I'm going to do difference over 2. Now I don't really need brackets here, but it just makes it easier to see. And I'm going to return the middle value. Okay, so now what I'm going to do is I'm going to say middle equals get middle, position 1, big number, small number. That's the middle number. We're then going to ceiling the middle number, and we're going to update seat position 1 to be that number. Okay, this is hopefully going to make things so much more easier. Okay, so we're then going to take this. No, not going to take this. Yeah. So middle equals get middle, row position, blah, blah. We're going to then ceiling that here, and we're going to say row position 0 is equal to middle. Okay, this feels very positive. Fantastic. So get middle. So we're going to put get middle in here as well. We're going to say get middle row position 1, row 2, and we are cooking by gas now. Okay, middle equals math.4, middle, lovely, row position 1 is equal to middle. Okay, I've got a feeling like this might be starting to work. Let's take this. Writing this tiny little function has just been a game changer. Let's think about how we're putting everything out. So let's put our get middle function up there. Let's take this here. Okay, fantastic. So let's run this. We've got an error, of course we do. Get middle. Why have I done 1 and 2? What a dingus. Okay, let's come down here. 1, 0, 1, 2. No, it's 1 and 0. Illegally. And let's take this here and pop it in here. Lovely. Let's run this. 49, 49, 0, 1. Okay, fantastic. So we've got seat 49 there. Is that right? No, it's not. We should have row 70. So something's going a bit wrong there. And it should be column 7. So I think we're probably just getting our ceilings and our floors around the wrong way. So B needs to take the upper half, F needs to take the lower half. Keeping rows 32 through to 63. How have I goofed up on this? This is like the same thing. 0, 32. Okay, so this should be 0 to 63 for B, right? Oh God, this is so confusing. No, it should be F that's 0. Okay, this is not my thing. Okay, so when we have our first F, it drops this 1, 2, 7 Oh, it's because we started with 32 and 63. What a wombat. 0, 1 through 7. Maybe that's just going to fix everything. 70. Yes, fantastic. And column 7. Okay, so we might just have these. Ah, ceiling and ceiling. Yeah, of course it's not going to work with ceiling and both. What a dingus. Okay, upper half means ceiling, lower half means floor. So let's do floor here. Let's run this. And we're still getting 0 and 1. Seat position, seat position, seat position. Oh, we're updating seat position 1 each time. But actually, when we take the lower half, we want to do 1. When we take the upper half, we want to do 0. Let's run that. Well, bam! Okay, we are in business. This is amazing. So what we should be able to do now is return an array that has, can you hear the joy in my voice? I'm so happy. Position 0 and seat position 0. It doesn't matter what index we take. We could take row position 1 because they're both the same. We can see here in the console that they are position 17, position 17, position 7, and position 7. So we have done it. We have done it. We have done it. We've done it. So what we're going to do is we are going to call this search boarding path to be more specific. And we are going to run this for each thing in test data. So what we're going to do is we're going to make another function, I guess, and we're going to say def search boarding, you guessed it, passes. That's going to take in our boarding data. And we're going to say for boarding paths in boarding data. So our boarding data is going to be an array of strings. We are going to say search boarding passes. What we're searching, we're putting in the boarding pass. Be like passport all over again yesterday. And we're going to say, I don't know, result. Let's say seat equal to search boarding passes. So this will give us an array with our row number and our seat number in it. Okay. So then what we need to do is we need to calculate our seat ID. So we're going to say seat ID is equal to. So we're going to do, how do we calculate this? We do the row times 8, add the seat. So multiply the row by 8. So our row is the first thing in seat. So we're going to say seat 0 multiplied by 8, add seat 1. And we are going to, what we're going to do, we are going to store that ID in an array. So what is it we're trying to solve? What is the highest seat ID on a boarding pass? Yeah, absolutely. So we're going to have an array of seat IDs. Let's keep it all okay. Seat IDs equals empty array. And we're then going to say seat ID dot append, and this will just add whatever our seat ID is to the end of the array. If it's empty, it will just add it as the first thing. If there's already something in here, it will add it as the second thing. Nice little function. Okay. And then at the end, we're going to return our seat IDs. And then finally, we can run our code. So we can say down here, search boarding passes. We're going to give it our test data, which it can use. And then what I'm going to do is I'm going to print the maximum value in our results. So I'm going to call this results. And I'm going to print, because it wants to know what the highest one is. So I think we can just say max in Python and everything will be fine. Let's see what syntax errors I've hit. Okay, I called it recursion error. Search boarding passes. Oh, okay, I want to search boarding pass. I'm sorry. I'm sorry, Python, I didn't mean to upset you. Okay, let's try that again. Name seat ID is not defined on line 41. Let's have a look. 41 seat ID dot append, get my plurals here. 820, and that is correct. This is the highest one out of these three. It's working. It's actually working. We are in business. Okay, let's not get too ahead of ourselves though. Okay, so we've got three lovely functions here. We've got a little bit of test data and we tested it and we know it's working. It's pulled out the highest seat ID. And so now what we're going to do is we're going to switch it up and we're not going to use the test data, but we're going to use the data that's been provided to us for this puzzle data. All of these boarding passes. So what we're going to do is we're going to, as always, use our little helper file and we're going to say helper.read file. And we're going to give it our file name. And I'm going to put the folder number first, because I always forget that. 2020/day5data.txt. It's day 5, isn't it? Yeah, day5data.txt. And then when we do this, instead of using test data, we're just going to swap this out. And because we've thoughtfully programmed this, we don't need to worry about changing anything. When we change the source of our data, we've programmed it. We know we're going to get our data exactly like this because that's what our read file thing does. It goes through every line of our text here, and every time it gets to a new line, it takes what was on the previous line and adds it to a list. So we end up with something like this, but much longer. Now, if I hit run, boom, 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 you've got to be joking me. 883. It is so close to the example in the test. It seems wrong. Okay, let's see. 883. Is that right? I mean, there's no reason it shouldn't be right, really. I was just expecting a higher number. In these things, I just expect it to be in like the millions normally. Yes, we got that star. I'm so happy. Okay, great, fantastic. Part 2. Let's see if we can get our 10th star of this series. Let's have a look. Okay, ding. The fasten seatbelt signs have turned on. Time to find your seat. It's a completely full flight, so your seat should be the only missing boarding pass in your list. However, there's a catch. Some of the seats at the very front and back of the plane don't exist on this aircraft, so they'll be missing from your list as well. Your seat wasn't at the very front or back though. The seats with IDs +1 and -1 from yours will be in your list. What is the ID of your seat? What? What? Okay. Okay. Your seat wasn't at the very front or back. Okay, so some of the seats at the very front and back of the plane don't exist on this aircraft, so they'll be missing from your list as well. The seats with IDs +1 and -1 from yours will be in your list. Okay. 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 Interesting. So I think what that's saying is, if there was a seat with ID 300 with 302, then that would be a seat that's +1 and a seat that's -1 from our seat. If our seat was 301, then those two would be in the list. So maybe what we want to do is we want to check. Do we just want to check for seats with IDs? This is difficult. So they'll be missing from your list as well. Your seat wasn't out the very front or back though. The seats with IDs +1 and -1 will be in your list. Okay. Your seat should be the only missing boarding pass in your list. I'm thrown by this sentence here. There's a catch. Some of the seats at the very front and back of the plane don't exist on this aircraft. I don't know what that... The seats at the front and back of the plane don't exist on this aircraft. As in, on the plane... They're not on the plane then, are they? I don't know what I mean. Some of the planes and seats at the very front and back of the plane don't exist on this aircraft. So they'll be missing from your list as well. Well, yeah, of course they will, because they don't exist. What does that even mean? Okay, let's just reread through this. Read through, patch on my seat, this airline, yep. This is the wording. Sometimes the wording of these puzzles really throws me. Okay, so let's assume that we're going to do this. So the seats with IDs +1 and -1 from yours will be in your list. So we want to find IDs that are if they are kind of two apart, two apart from each other. Okay. So we want to make a function, and we want to call is two, and we are going to take in two numbers, so num1 and num2. We are going to say if num1 minus num2, if num1 minus num2 is equal to 2. So in my example down here, if I did 300 minus 2, I would get minus 2. Okay, and if I did 302 minus 300, I would get 2. Okay, if num1 minus num2 is equal to minus 2, or num1 minus num2 is equal, then we are going to return true. Else we are going to return. So once we get our list of boarding passes, we've got all of our boarding passes here, we're then going to go through those and find the ones that are two apart. So we're going to make a function called check boarding passes. And we want a boarding pass list to be passed in. And we are going to say for boarding pass in boarding pass list, we want to check whether it's two apart. So actually what we really want to do, we're probably going to want to use two loops, aren't we? Yep, we are. Okay, let's do for I in range. We want to know what position we're at. So we're going to say length is equal to len of boarding. I'm storing this in a variable because I'm going to have to use it twice. I don't want to type out boarding pass list twice. So in range length, and we're going to do length minus 1. I'm going to say for j in range length, and we're going to start from 1 rather than 0. This is going to start from 0. It starts automatically, but I'll put 0 in there just so it's clear. So this is going to start 1 ahead, and it's going to finish 1 later. This is going to start 1 behind, and it's going to finish 1 behind. So this will cover the whole array here. And what we're going to do is we're going to check if the thing in the first position, at position 0 in the boarding pass list, so this one, or well, the ID, so this one, and we want to then check with the thing in the first position. So let's say this one. So we want to check 567 against 119 and see whether they are two apart. Then what we're going to do, if they're not two apart, we then want to check, we're then going to, j is going to increase by 1, so it's going to become 2. And so we're going to still have I as 0. So this is still going to be 567, but we're then going to check 820 against 567. So this will allow us to check 567 as 119, 567 against 820, and then I will become increased by 1, so I will be 119, and it will check with 820. So we can check all the numbers against each other. So we are going to say if is two apart, what we want to do is say boarding pass list I, boarding pass list j. They are two apart. Then what we want to do is we want to, let's make a valid, let's call it surrounding passes, and a list, and let's just see if we get any surrounding passes. I could be going at this completely wrong, but like I'm a bit perplexed as to what this is actually wanting us to do. So we're going to say surrounding passes dot append. We're going to append boarding pass list at position I. we are going to append. And what I'm going to do is I'm just going to get this to print out our surrounding passes. Okay, fantastic. So let's run this then. So we get our results. We print out on. We're not printing this very nicely, are we? Let's print out the highest boarding pass C is. Put a comma. That means you don't have to cast it into a string, which is fantastic. And then let's get rid of this. We don't need to do this. Then we're going to come down here and we are going to say check boarding passes with our results array. So that will be our list of boarding passes. Yeah, this is a boarding pass ID list, I guess. I'm not going to update it. We know what it is. There's too many. Let's take this and we're going to say that. And we're going to use results. And then we're going to print. Oh no, it prints itself. That's what it does. Oh, Lily. Okay, there are a lot that are. Oh no, there's so many. There's so many that are distanced by 2. Okay. No. We know that our pass isn't in here. Okay. So as well as them being 2 apart, we also need to know whether the thing in the middle of them exists. So in my example down here, when I had 300 and 302, it's all very well if they're separated by 2. Great, okay. But we need to check that 301 doesn't actually exist, because if it exists, we don't want to log it in our array. Because we know it tells us in here that our the only missing boarding pass in your list. So your seat should be the only missing boarding pass in your list. So we know it's the only one that's missing. So if it's there, we know it's not our seat. So what we want to do is we want to check in this boarding pass list to see whether our thing is in there. So we're not going to store surrounding passes at all, actually. We're going to call it potential seat. We're going to say if that, and then we could put another condition in here, but I just want it to be kind of simpler and easier to see. So I'm going to say if we want boarding pass lists I. Now, how do I know whether I need to add one or take one away from it? That is the question. That is the question. Let's write a function. Let's call this def get. Oh no, we can use the max, can't we? Yeah. No, we can use the max function. If max. So we've got our 2 candidates. So let's call this candidates because these are the surrounding. These are the surrounding passes here. Surrounding passes equals, and we're going to pop in boarding pass list I and boarding pass list J, and then we're going to say if the max value of in surrounding passes -1 is not in our boarding pass list, then we're going to take this, and let's call this potential seat. So we're going to say potential seat. What am I doing? What? Oh yeah, potential seat equals this. I copied something, but I can't remember what I copied. So our potential seat is max surrounding passes, so the biggest pass out of these 2, and we're going to take 1 away from that because we know it's going to be 1 bigger than our potential seat. If our potential seat is not in the boarding pass list, then we're going to say potential seats dot append are potential seats. Oh, okay. Then we are going to print out our potential seats. And if all is well, this will just print out one seat and it will be great. Otherwise, we might have to embarrassingly just try putting in a few. Let's have a look and run this. Okay, let's cancel all of this and let's run this again. No, not cancel, clear it. Let's clear that. Okay, lovely. Let's run this. Thinking about it, 532. 532. We've got our seat. We've got it. It put the same number in twice. That's amazing. Okay, because obviously it must have done one and then the other. Yeah. This is great. This is so good. Okay. 532. This will be under an hour. This will be better than yesterday's performance if this is right. But it's going to be wrong. And I'm going to have to refactor everything. It's going to be a nightmare. Let's have a look. It's not wrong. We did it. We did it. We did it. We did it. We are 10 stars in to Advent of Code. Oh, fantastic. So we did a binary search today. We were halving our data and sorting through it. And we've been able to solve this. And then we had that really funny little thing at the end about seats that didn't exist on a plane and the plane didn't exist or something. But we managed to do it. We managed to work our way through it. Okay. And we now have our code here that has produced us the result. This is fantastic. And if we go back to the Advent calendar here, see that we've now got 2 stars for all 5 days so far and only 9 hours. I know you can't wait. 9 hours until the next challenge is released. And I will see you on day 6. Thank you for watching.